Have you ever opened up a legacy codebase, just stared at this massive, totally tangled block of if statements, and suddenly realized, wait, this isn't a technical problem, this is a complete misunderstanding of what the business actually does? Honestly, the absolute biggest risk in complex software is not bad code. No, it is misunderstood business logic hiding inside bad code.
So, welcome to this explainer of Eric Evans' definitive book, Domain-Driven Design. Our main objective today, we're going to tackle that crippling complexity that literally brings down our most ambitious systems. We'll be exploring why this methodology even exists, the exact problem it's trying to solve, and why, time and time again, incredibly smart engineering teams fail just because they ignore the domain.
Now, the really crucial point here is understanding what we call the domain complexity trap. Think about it. On one side, we've got technical complexity. The visible machinery, the databases, the network protocols, the shiny new UI frameworks. And as engineers, let's be real, we absolutely love this stuff. We will happily spend 3 weeks arguing over Kubernetes configurations, right? But then on the other side, there's domain complexity. This is the hidden engine of the software. It's the messy, often contradictory business rules of shipping logistics or high finance or healthcare. And here is the trap. We constantly try to solve domain complexity by just throwing more tech at it. But if the domain isn't modeled right, your pristine microservices architecture is still going to fail, for sure.
To really illustrate this, Evans starts the book with this brilliant tale of 3 projects. It's essentially a real-world teardown showing how completely different approaches to design ultimately seal a system's fate. We're looking at a quick map of 3 distinct trajectories here. Honestly, we've all likely seen these, or if we're being honest, maybe even built them ourselves. There's the fast collapse, the disconnected failure, and then our ultimate goal, the virtuous cycle. So let's break down exactly what happens in each of these scenarios.
All right, first up, Project 1, the fast collapse. Now, this project flew out of the gates. The team delivered a simple web system super quickly, and obviously business expectations just skyrocketed. But they completely ignored domain design, they didn't have a common language, and by version 2, bam, they hit a brick wall. The whole system prematurely ossified into this high-maintenance legacy nightmare. And notice what actually killed it. They weren't crushed by bad technology. No, they were crushed by the weight of their own unmodeled spaghetti business logic.
Next is Project 2, the disconnected failure. Now, this is an interesting one because this team actually cared about modeling. They had these really lofty goals and super smart architects, but they still failed. Why? Because they treated design and coding as completely isolated activities. You had people drawing these beautiful, elaborate UML models who weren't actually writing the code, and then the developers writing the code didn't even understand the models. Because of this massive chasm, repeated iterations brought literally zero actual improvement to the codebase. Eventually, they just lost their cohesive vision and, well, surrendered their ambitions.
And that brings us to Project 3, the virtuous cycle. Now, this is the gold standard. Just like the first project, they started out with some modest success, but instead of hitting a wall, they actually accelerated. And the secret? They repeatedly refined an incisive domain model and then expressed it directly in their code. They actually built a shared ubiquitous language between the developers and the domain experts. So instead of degrading into this legacy sludge over time, the code actually became easier to modify as their insight into the business grew, a real game changer.
Okay, so if Project 3 is the obvious goal, you really have to ask yourself, why do we keep falling into the traps of those first 2 projects? Like, why do senior engineers and brilliant architects keep building systems that literally collapse under their own weight? Well, the answer actually lies in our own engineering biases.
It basically comes down to the technical distraction. Let's be completely honest with ourselves here. We absolutely love quantifiable problems that exercise our technical skills. Domain work? It's messy. Learning the intricate, boring rules of a shipping manifest just doesn't look as cool on a resume as, say, building a custom caching layer from scratch, right? So all that top-tier technical talent goes to work on these elaborate frameworks. We beautifully abstract away the database, but then we hard-code the core critical business logic into a tangled, unreadable mess. We entirely leave the actual business rules behind.
So how do we punch through this complexity ceiling? Well, Evans introduces the definitive solution for this, and it's built upon 2 non-negotiable rules.
Here they are. Number 1, for most software projects, your primary focus absolutely must be on the domain and the domain logic, not the framework, not the database, the domain itself. And number 2, complex domain designs must be based on a model. You see, domain-driven design isn't just some new coding pattern, it's a whole different way of thinking. It's aimed specifically at accelerating projects that deal with really complicated, real-world domains. To put this into perspective, think about an astrolabe, that ancient mechanical tool used to compute star positions. Evans uses this to just brilliantly illustrate what a model actually is. Because an astrolabe isn't just some pretty abstract picture of the sky, it is a mechanical implementation of a model of the heavens. In software, it's exactly the same. Your domain model shouldn't just be a theoretical diagram on a whiteboard. It has to be mechanically tied to the implementation. Basically, the code is your astrolabe.
But to actually make this work, we have to completely shatter this old-school illusion that has kind of poisoned our industry. We really need to accept that the manufacturing metaphor for software is fundamentally broken. Building software is not some assembly line, where elite architects draw up blueprints and then hand them off to less skilled laborers who merely type out the code. That just doesn't work. In fact, Evans states it incredibly boldly. He says, software development is all design. Programmers are modelers, whether anyone likes it or not. Think about that. Design concepts absolutely have to be implemented successfully in the code. Otherwise, they just dry up into these useless academic discussions. Seriously, if your hands are on the keyboard writing the code, you are designing the system. You are modeling the business. Period.
And honestly, this perfectly explains why ivory tower architecture always fails. When you have these hands-off modelers, the crucial intent behind the model gets completely lost in the handoff. There's basically zero feedback loop from the gritty reality of the code back up to the model. And over time, those models just degrade into mere data structures. Remember, refactoring the code actively changes the model. Because of that, the team writing the code must feel intimately responsible for it. You simply cannot separate design from the actual development process.
So, that brings us to the big question. How do we actually execute this? Conquering domain complexity requires a highly structured path, and that's exactly what we're going to be covering as we explore the rest of this source material.
We're going to be neatly dissecting the 4 major parts of the domain-driven design methodology. First, we'll start with putting the model to work, focusing heavily on communication and building that ubiquitous language. From there, we'll dive right into the building blocks. These are the actual code-level patterns you need to isolate your domain from your infrastructure. Third, we'll explore refactoring toward deeper insight, showing you how to turn messy, rigid code into a supple, flexible design. And finally, strategic design, which will give you the architectural tools you need to maintain model integrity across massive, complex enterprise systems. The whole shebang.
But before we wrap up, I want to leave you with a final, slightly provocative thought to take back to your desk today. The next time you sit down and open your IDE, ask yourself, are you just writing code, or are you actually modeling the business? Because if your code doesn't reflect the true reality of the business domain, I promise you, all the technical perfection in the world is not going to save it. So take some time to think critically about the hidden engine of your software, and I'll catch you in our next explainer.